So that was concentration change. What if we change the volume? Well, this happens or applies mostly towards gases, because gas concentrations are very much dependent on the volume of the container. When we change the volume of a gas sample, we change its pressure. If we decrease the volume, if we squeeze it together, that's an increase in pressure. If we increase the volume, that causes a decrease in pressure. If we lower the number of moles of gas by removing some, that's going to cause a lower pressure. Pressure is directly proportional to the number of moles of gas. You put more gas in, the pressure is going to be higher. So a system can relieve a pressure change by changing the moles of gas. So here is a sample reaction. Here's ammonia being formed from nitrogen and hydrogen. In the reactants, if everything was in the reactants, we'd have 4 moles of gas, 1 mole of nitrogen and 3 moles of hydrogen. If we forced all of that to react into ammonia, we'd end up with 2 moles of gas particles. The pressure-volume-temperature relationship of gases with the moles depends on the number of particles, not on what kind of particle they are, because the actual volume of a gas particle is negligibly small compared to the total volume of the sample. So if we push the plunger down on this and cause the volume to shrink, that increases the pressure of the gas. Le Chatelier's principle says this equilibrium is going to shift to reduce the pressure. Well, if it goes towards the products, it's going to have half as many moles of gas particles as if it was all in the reactants. So by shifting towards the reactants, it can reduce the pressure, and that's what it will do. If we increase the pressure, increase the volume. If we increase the volume, that causes a decrease in pressure. And you might think, well, the gas wants lower pressure. No, the equilibrium wants what it had before. Don't rock the boat. So if we reduce the pressure, the equilibrium is going to shift to increase the pressure. And so reducing the volume decreases the pressure, and then this is going to cause the equilibrium to shift to the side that has more gas particles. You identify how many gas particles by just looking at the balanced chemical equation and counting up how many moles of each gas substance. Here they're all gases, and so we have 1 nitrogen, 3 hydrogens. That's a total of 4. And over on the right we have 2 ammonia molecules, and so that's 2. So it will shift towards the side with more gas particles. Summary of that: decreasing the volume will cause the reaction to shift to the side that has fewer moles of gas. Increasing the volume causes it to shift in the direction that has more moles of gas. What if both sides have the same number of moles of gas? Then changing the volume doesn't affect the equilibrium at all. So, an example. Consider this reaction at chemical equilibrium. So we have 2SO2 plus O2 in equilibrium with 2SO3. What is the effect of decreasing the volume? Shift right or shift left? So I always have to think this through. So decreasing the volume, cut the volume in half, say, that's going to increase the pressure. How can the reaction counteract that, decrease the pressure? So it will want to shift to the right, because on the left side we have 3 moles of gas, on the right we have 2 moles of gas. So decreasing the volume will cause it to shift to the right. Increasing the volume decreases the pressure. It'll shift to the side with more gas particles. It'll shift to the left. These are questions that you really, they'll show up on an exam, and you have to sit there and be able to think through it clearly to choose the right direction. Any questions? Now we're getting to